Hello everyone. So today we are going to see shortcut case 2 to find yp, to find particular integral. So if right hand side function of the differential equation is sin ax plus b or cos ax plus b, then what is your yp? Okay, so yp is equal to 1 upon phi of d square sin ax plus b, where phi of d square is the auxiliary polynomial in the particular differential equation you have. Now phi of d square, why we are calling it as phi of d square? Because all even ordered derivatives of sine are sine, all even ordered derivatives of cos are cos. So just we are calling the auxiliary polynomial as phi of d square. In other cases we call the auxiliary polynomial as phi of d, but in this case we call it as phi of d square. So yp is equal to 1 upon phi of d square sin ax plus b. So in the example you have to compare angle of sine with that particular angle in your problem, okay, and you have to find value of a. Then after finding value of a, you have to replace d square by minus a square. Okay, so replace d square by minus a square, that is your answer. So phi of minus a square sin ax plus b, this is your answer. Now what this means? This means d square is replaced by minus a square. Okay, if you have cos, then we have to do same thing. Okay, for example we are taking sine because sine and cos are trigonometric functions, and for both of them this case is applied. Okay, so phi of 1 upon phi of d square sin ax plus b is equal to 1 upon phi of minus a square sin ax plus b. So simply you have to replace d square by minus a square, provided that, what is the condition provided? Phi of minus a square is not equal to 0. Okay, this term must be non-zero, then and then only this will be defined. Okay, so if this is 0, then what we have to do? If this is 0, then we will do the same thing what we have done in exponential case. Okay, we have to take x in the numerator and we have to differentiate phi of d square. Okay, phi of d square with respect to d. So yp, if phi of minus a square is equal to 0, then yp is equal to x upon phi dash minus a square sin ax plus b. क्या किया हमने यहाँ पे? न्यूमरेटर में x लिया है और डिनोमिनेटर में phi का डेरिवेटिव निकाला है विथ रिस्पेक्ट टू d. नाउ you will differentiate with respect to d only. Just we are calling phi of d as phi of d square in this case, nothing else. Okay, so yp is equal to x divided by phi dash minus a square sin ax plus b, provided that phi dash minus a square is not equal to d 0. Okay, so if phi dash is 0, if phi dash is also 0, then you have to increase power of x in the numerator, and in the denominator you will have second order derivative evaluated at minus a square. So if phi dash at minus a square is equal to 0, then yp is equal to x square divided by phi double dash at minus a square sin of ax plus b, provided that this denominator must be non-zero. Okay, so phi double dash at minus a square is not equal to 0. Now in case of cos also we will have same formulae, just you have to replace sin by cos. Okay, you may have a lot of extensions of this formulae. Okay, you may have different r number of formulas or n number of formulas, but everything is obtained from this main formula. Okay, so you have to keep in mind what is the strategy we are using to develop this formula. Okay, what is the strategy used in this formula, you have to keep in mind. Okay, so we will take one example. to understand how to apply this while solving differential equations. So solve d square plus 4 square operating on y is equal to cos of 2x plus 5. Okay, so what is the angle in this case? Angle is 2x plus 5. So ax plus b compared with 2x plus 5, which implies that a is equal to 2 and b is equal to 5. Okay, now auxiliary equation in this case is d square plus 4 bracket square is equal to 0. This is your auxiliary equation. Now d square plus 4 is equal to 0 implies d square is equal to minus 4. Okay, that means d is equal to under root minus 4. We know that a perfect square of every real number is always greater or equal 0. You have under root negative number, that means roots must be imaginary. Okay, so under root minus 4, it can be written as under root minus 1 into under root 4. Okay, under root 4 is plus minus 2 and under root minus 1 is plus minus iota. So combining both the roots, you will have plus minus 2i as your root of this equation. D square plus 4 is equal to 0. Now d square plus 4 is repeated one more time. Okay, so roots corresponding to d square plus 4, the pair will repeated once. Okay, so plus minus 2i. So what is the value of d? Sorry, write it separately. So d is equal to plus minus 2i plus minus 2i. Now you have complex conjugate pair as your roots. Okay, and it has repeated once. Okay, एक minute. Okay, so roots are imaginary and repeated. So yc complementary function yc in this case is equal to, you have imaginary pair repeated. Okay, so you have to take, and real part is 0. Okay, so what is your in general yc? It is e raised to real part into x into bracket c1 cos of 2x plus c2 sin of 2x. But here you have repeated plus minus 2i as your root. So you will get c1 plus c2x. How many times plus minus 2i is repeated? Repeated once only. So you have to add c2x. Okay, if it is repeated twice, then you will have c2x plus c3x square. But in this case, it is repeated once only. So c1 plus c2x cos of 2x plus c3 plus c4x sin of 2x. Now count arbitrary constants in your CF. Number of arbitrary constants must be equal to order of the differential equation. So you have 4 arbitrary constants here, and order of the differential equation is d square its square. That means 4th order differential equation you have. So that means your answer is correct. So CF is equal to this. Pi is equal to yp is equal to 1 upon phi of d square. जनरली हमें आदत हो जाती है कि हम ये जो ऑक्सिलरी पॉलिनोमियल है उसको phi of d बोलते हैं, लेकिन यहाँ पे इस केस में आपको उसको phi of d square ऐसे बोलना है. सो 1 upon phi of d square operating on cos of 2x plus 5. This is your yp. Now we have already compared what is a and b. So a is equal to 2 and b is equal to 5. So yp is equal to, what we do, we replace d square by minus a square. So in this case a is equal to 2, so minus a square is equal to minus 2 square, that is minus 4. So we have to replace d square in auxiliary polynomial. What is auxiliary polynomial? D square plus 4 bracket square cos of 2x plus 5. So here we have to replace d square by minus 4. Minus 4 plus 4 will be 0. Okay, minus 4 plus 4 will be 0. So this is not valid. So if phi of minus a square is 0, then what we do? Phi of minus 4 is equal to 0, which implies that yp is equal to, take x in the numerator, okay, and take derivative of the denominator. So derivative of d square phi dash is equal to 2 times d square plus 4 multiplied by derivative of this d square plus 4, it is 2d. So simply what is phi dash? It is 4d multiplied by d square plus 4. Okay, so x divided by 4d d square plus 4 operating on cos of 2x plus 5. Okay, so yp is equal to x into bracket 1 by d square plus 4, 4 times d square plus 4, 1 by d operating on cos of 2x plus 5. Now you have cubic polynomial here, okay, in the numerator, in the denominator, and we need all even degree terms. So 1 by d is separated, okay, 1 by 4 times d square plus 4 into d, it's separated like this. So 1 by d is what? 1 by d is inverse differential operator. 1 by d works as integration, okay. So yp is equal to x times 1 by 4 d square plus 4. 1 by d is simple integration, so cos of 2x plus 5 dx. So yp is equal to x times 1 by 4 d square plus 4 integration of cos, it is sin 2x plus 5 divided by coefficient of the angle. What is the coefficient? It is 2. Coefficient of variable in the angle, okay. So coefficient of x is 2, so divide by 2. Now this 1 by 2 is constant, take it outside. So yp is equal to x by 2 into bracket 1 upon 4 d square plus 4 sin of 2x plus 5. So yp is equal to x by 2, yp is equal to x by 2. Again you have d square plus 4 inside, x by 2 you can take this 1 by 4 also outside the bracket, okay. So 1 by d square plus 4 sin of 2x plus 5, okay. So yp is equal to x by 8, 1 by d square plus 4 sin of 2x plus 5. Again you have d square plus 4 and a is equal to 2. So that means after replacing d square by minus 4, this will be 0. Okay. So again you have to differentiate inside. Keep this x by 8 as it is because it is outside the inverse differential operator. Okay. So it is just a multiplier. So yp is equal to x by 8. Inside you will have x divided by d square plus 4, derivative of d square plus 4. Why we are taking derivative? Because d square plus 4 is 0 after replacing d square by minus 4. Okay, so we have to apply the same case again. Okay, so x divided by derivative of this phi of d square. Now phi of d square in this case is d square plus 4 for this bracket. Okay, so d square plus 4, derivative of d square plus 4 is 2d sin of 2x plus 5. Again you have 1 by d, simple 1 by d. Taking this x by 2 outside the bracket, you will have yp is equal to x square by 16, okay, 1 by d sin of 2x plus 5. So now you have two choices. Either you can multiply numerator and denominator by d, so that denominator will be converted in d square and you can replace that d square by minus a square. Or else what you can do, you can simply take 1 by d as integration. Okay, 1 by d works as integration, so you can use it also. So yp is equal to x square by 16 integration sin of 2x plus 5 dx. So yp is equal to x square by 16 integration sine 2x plus 5, same thing, integration of sine is minus cos, so minus cos 2x plus 5 divided by 2. Okay, why divided by 2? Because after integrating sine ax we will have minus cos ax divided by a. So a is what? A is multiple of the variable in the corresponding integrand. Okay, integrand angle. So yp is equal to minus x square by 16 to the 32 cos of 2x plus 5. So we have used the same case how many times? We have used the same case for 3 to 4 times, but at final substitution we have used 1 by d as integration. You can also use the same case by multiplying and dividing by d. Okay, that means d will convert it to d square and you can replace d square by minus a square. Okay, now the length of this problem is this problem is lengthy, but you don't have to remember a lot of formulae in this case. Okay, just only for one formula you have to remember, and that is shortcut case 2 for sin ax plus b or cos ax plus b. And if you do step by step all these calculations precisely, then you will definitely get calculations corrected. Okay, another way of solving the same problem is you can use formula 1 upon d square plus a square raised to r cos of ax plus b is equal to minus x by 2a raised to r 1 by r factorial cos of ax plus b plus r pi by 2. Okay, this is the formula you can use for the same problem we have just seen. Okay, but I think to remember this formula, okay, to remember this formula is little bit difficult, so you can straightforward use the same case you have for sin ax plus b and cos ax plus b. Okay, thank you.